AI agents already changed software, but this week Google made the stronger claim. The next agents will move through the real world, use tools, and work together. That is a much bigger idea than another model release, because once AI leaves the browser and starts operating around shelves, tools, carts, bins, doors, machines, and people, the standard for smart changes completely. It is no longer enough to generate a clever answer or complete a coding task. A physical AI system has to understand space, timing, safety, failure, recovery, and coordination. It has to deal with the fact that the real world does not behave like a clean prompt box. That is why Google's Gemini Robotics ER2 launch matters. On July 30, 2026, Google published a new post introducing Gemini Robotics ER2. The company describes it as a high-level brain for robots. That phrase sounds like marketing, but it is actually a useful way to think about what changed. The model is not replacing every low-level motion controller in a robot. Instead, it sits above those systems, understands instructions, reasons about the room, breaks work into steps, uses tools or APIs when needed, and keeps track of whether the task is actually progressing. That distinction is important. Most robot demos look impressive because they show a narrow success case. Pick up this object, walk to that point, open a drawer, stack a block, pour a drink. The clip looks magical, but the real question is always what happens when the task gets longer, the environment changes, a step fails, or another machine and a human enter the scene. That is where many robotic systems stop looking like products and start looking like research projects. Google's pitch with ER2 is that the industry has to move beyond single-action tricks and toward longer, more realistic workflows. The company says Gemini Robotics ER2 can process video, audio, text, and images, use function calling, and orchestrate lower-level action systems in real time. In plain English, that means a robot can watch what is happening, think about what comes next, and keep acting without the awkward stop-and-think rhythm that makes many physical systems feel brittle. That is the first reason this matters. Fluid orchestration. If you want a helpful robot in a warehouse, lab, hotel, grocery back room, or industrial facility, you do not want it freezing every time the situation changes. You want it to keep moving through the workflow, notice what changed, and recover when something goes wrong. Google claims ER2 improves that loop in several concrete ways. One of the biggest is progress tracking. The system watches a continuous video feed and estimates how far along a task is, frame by frame. That sounds small until you realize how much of robotics depends on knowing whether the job is actually done. Tighten the bulb, seal the bag, pour the liquid, put the item in the correct bin. These are not just yes or no actions. They have middle states, failure states, almost done states, and do not move yet states. In its post, Google says ER2 reaches 57.4% accuracy on progress classification and 91.3% accuracy on moment finding, which is the ability to identify the exact moment when a critical event happens. The company also says the system does this at much lower latency than giant video models that are not built for physical action. That matters because in robotics, timing is part of intelligence. A chatbot can be slightly late and still feel useful. A robot can be slightly late and spill, collide, misgrip, or ruin the handoff to the next step. This is where the story becomes more interesting than a normal model upgrade. ER2 is not only about better perception, it is about a different operating style for machines. Instead of one monolithic robot brain doing everything, Google is pushing a layered setup. The embodied reasoning model acts like the planner and supervisor. Lower-level vision language action systems or navigation tools do the motor work. APIs and tools expose capabilities. The top-level model decides which capability to call, when to wait, when to retry, and when to move on. If that pattern sounds familiar, it should. It is basically the agent pattern from software brought into the physical world. And that is why I think this launch matters far beyond robotics people. The software world already learned that agent systems become more useful when they can call tools, hold state, recover from mistakes, and work through multi-step tasks. Physical AI is now trying to do the same thing around motion, manipulation, and space. Google also paired ER2 with a broader Gemini Robotics 2 story, and that fills in the second big piece, embodiment. According to Google DeepMind, the system can now support whole-body control for humanoid robots, not just upper-body table tasks. It can also handle stronger dexterity across different end effectors like hands and grippers. In practice, that means robots are not just reaching across a bench anymore. They are bending, walking, placing, carrying, coordinating arm movement with body movement. and attempting more delicate actions that look closer to real work. This does not mean robots suddenly became human-level workers. Not even close. Google's own examples show why. Some dexterity tasks remain hard. The company is open that movement speed, precision, and reliability still need work. Multi-finger manipulation remains challenging. Human-level adaptability is still far away. But the important shift is that the system is trying to manage longer chains of activity rather than isolated tricks. That is the kind of progress that starts to matter commercially, because the first real winners in physical AI probably will not come from robots replacing every worker in a general environment. They will come from constrained environments where the economic math already hurts. Warehouses with repetitive picking tasks, logistics hubs with handoffs between stations, labs with repetitive materials movement, factories with routine packing and kitting, facilities that need inspection and simple intervention, and workplaces where labor shortages or turnover make consistency valuable. Think about what businesses actually buy. They do not buy the future. They buy throughput, reliability, lower incident rates, lower labor bottlenecks, and fewer broken handoffs. If a physical AI system can coordinate a mobile robot, a manipulator, and a human teammate well enough to save real time in a narrow workflow, that is already a meaningful business event. This is why multi-robot collaboration may be more important than the humanoid headlines. The internet loves the idea of one heroic robot that does everything. Real operations may care more about a system where different machines do different parts of the job and share context. One robot navigates, another manipulates, another scans or verifies. The reasoning layer coordinates the workflow and decides when to pass the task across machines. That is a much less cinematic story, but it is a much more believable path to value. It also matches how modern computing usually wins. Not one perfect machine, a coordinated stack. There is another reason this launch matters. It turns robotics into a much clearer platform race. Google is not only showing a lab demo, it says ER2 is available through the Gemini API, Google AI Studio, and in private preview on Gemini Enterprise Agent platform. The developer changelog lists dedicated preview endpoints for robotics, including a streaming version optimized for low latency interaction. That tells you Google wants developers, integrators, and enterprise partners building on the stack now, not someday. Once that happens, the question changes from can Google build a cool robot model to can Google become part of the default operating layer for physical automation. That is a huge strategic prize. If software agents become one platform race and physical agents become another, the winning companies are not only selling models, they are shaping ecosystems, developer tools, safety layers, cloud workflows, simulation loops, deployment infrastructure, and enterprise integration. In other words, robotics starts to look less like a moonshot side quest and more like the next expansion pack for the AI platform economy. Of course, there are still real blockers. Speed is one. Reliability is another. Cost is another. Safety is the big one. Google leans hard on the safety angle, saying ER2 improves human proximity awareness and can stop work when someone gets too close. That is encouraging, but every robotics company says safety matters. The real test is whether these systems remain predictable when they move from controlled demos into noisy, messy, semi-chaotic workplaces with imperfect lighting, awkward objects, changing floor layouts, and humans who do not behave like benchmark scenarios. Then there is deployment friction. A useful robot is not just a good model, it is hardware maintenance, battery management, integration work, site-specific adaptation, operator training, uptime, fallback procedures, and a business case strong enough to justify all of that complexity. That is why physical AI will probably scale slower than software agents even if the technical progress starts looking dramatic. But slower does not mean unimportant. In fact, that may be the real takeaway from this week. For a long time, robotics progress often felt like a separate internet category. Cool videos, research headlines, impressive prototypes, and a lot of someday. What changed here is that the framing is finally getting closer to how businesses think about useful systems. Reasoning layer, tool use, long-running tasks, workflow orchestration, human interaction, safety controls, platform access, preview endpoints, enterprise rollout path. That starts to sound less like science fiction and more like product strategy. So if you want the simplest possible version of the story, it is this. Google is trying to make robots less like isolated machines and more like embodied agents. The big promise is not that one robot can do one cool thing. The big promise is that AI can supervise, coordinate, and adapt across longer physical workflows. If that promise holds, The first big wins may show up in boring places before flashy ones: storage rooms, factory cells, shipping zones, labs, and industrial back-end operations. And if those wins show up, the physical world becomes the next serious arena for the AI platform fight. That is why this launch matters even if you are not planning to buy a humanoid robot. It suggests the next chapter of AI competition will not only be about smarter chatbots, cheaper inference, or better coding agents. It will also be about who can connect intelligence to action in the messy real world. Physical AI still has a long way to go, but this week, it stopped feeling like a sideshow. It started feeling like a real race. And that is why physical AI just stopped looking like a lab demo.